Hi, it is Miss Cram again. So today we are going to go over the October 12th and 13th, so the Desmos that you just completed. And again, like all of the videos I will make and the one that I made before, you can skip through if you have a specific slide that you'd like to go over. I'm going to try to hit all of the slides that were requested. So the last slide of each assignment, I'm going to try to make just like, tell me how the lesson went. Tell me what slides you would like to, really focus on. And yeah, so we will get started with that. I also just want to mention that you're not given technical like homework now at this time, but you are expected to finish the Desmos activity that you did in class and to watch these videos, especially to sort out any issues that you're having or any trouble that you're going through with these. Also, email me anytime. And big shout out to Section 6, which I guess goes on Tuesdays and Thursdays. You as a class have just been amazing at finishing or being close to finishing all of the slides. So huge shout out to you all. And, all of the other sections, let's see if we can get more of those slides finished. All right, so let's get started. All right, so we were talking about a little bit how we felt. I like reading them, so, do those warm-ups. The lesson goal today is to figure out that polynomials can be written in standard and factored forms. Oh, it doesn't let me highlight. Okay, whatever. So standard and factored forms. Let's see. Yeah. All right, that's the big thing. What can you tell when it's in standard form? Hint, hint, y-intercept and the degree. And what can you tell when it's in factored form? Again, hint, hint, x-intercepts, also known as zeros. All right, so we have which one doesn't belong. I'm actually going to skip through to slide 11 because for this one, you can see the summary here. And for the next few slides, these are reviews. So we did this, if I taught you in algebra, or if somebody else taught you in algebra, we did all of these and they have videos right after. So I'm not gonna just redo all of those. Okay, so let's go to slide 11. Get this party started. Okay. All right, let's see. So here, they want you to identify the degree and the leading term of this polynomial. All right, so take a second. What form is this in already? Okay, I hope that you said factored form. All right, factored. Okay, so we're just going to say factored form, right? And that's because in each of these parentheses, that's a factor. All right. That does not tell me, though, the degree that it is or the leading term. In order to find those easily, it's a lot better to put it into standard form. All right. So if I am over here, I'm just going to rewrite this and I'm going to see maybe they'll let me use this. Ooh, all right. How nice. Okay. So here, I'm just going to rewrite it. Okay, so again, my goal here is to write this in standard form. All right, so I'm going to pick two of the factors. I can't multiply all three simultaneously, just like if you did like 2 times 3 times 5, right? If you're multiplying, it doesn't matter the order that you do it in, but you could only multiply 2 at a time, right? I could say, all right, 2 times 3 is 6, and then 6 times 5 is 30. Okay, so I'm using that same concept of I've got 3 factors, right, all in their own parentheses, and I'm just going to multiply 2 of them first. So I'm going to do the first 2. If you want to do some different order, great, go for it. All right, so 14 times 8.5. All right, let me get my calculator. I probably should have done this beforehand. Sorry, guys. All right, so 8.5 times 14. Okay, so that gives me 119. 119. All right, and then I'm going to do 14 times -2. All right, that gives me -28x. All right, so now I'm going to go, let me maybe change colors. So I'm going to start from this -2x times 8.5. So that would be 17, -17x. Okay. And then -2x times another -2x would give me a positive 4x squared. Remember, x times x, x squared. All right, now I still have this third factor here. So I've got to put all of this in a parentheses, and I'm multiplying it by x. Now, if it makes you feel more comfortable, you can move this x to the front, right? Either way you want to do it. In fact, why don't we do that? Why don't we just all right, actually, maybe why don't we not do that, because I can't figure out how to do it. And so we're just going to go this way. But no, it wouldn't matter if you moved the x to the front. Same thing. So I'm going to do distributive property again. X times 119 gives me 119x. I'm going to actually combine these. All right, so -28 minus 17. Okay, that would give me -45x. So I'm going to multiply that by the outside x. So minus 45x, right? Remember, -28 minus 17 is how I got that -45. X, now x times x, right? I'm doing both of these. X times x is x squared. And then x times 4x squared would give me 4x. I hope you're thinking in your head, right? 4x to the third. All right. So let me just rewrite this one more time in standard form. And so I'm going to write, all right, let me give myself space. V of x. Now think to yourself, what would go first? All right. So I hope you remember that in standard form, the term with the highest exponent is written first. Sorry about that. All right, 4x to the third. And this is what we call our leading coefficient is the 4, and our leading term is the whole thing. All right, so this is my leading term with a leading coefficient of 4 and a degree of 3. All right, and then I'm just going to write the rest. And remember, it's got to go in order by exponent. So the x squared term goes next. And the positive, remember I look in front of it, right? So the positive 119x goes last. Positive 119x. Okay, cool. All right, so now I can identify the degree, right? When they say the degree of the polynomial, they're always talking about the highest degree. So this is a third degree polynomial, and the leading term is, let me see if I can type this because it's a little easier. The leading term is the entire 4x to the third. Okay, so I'll put it right underneath this 4x to the third, the whole thing. Okay. There we go. All right, so explain or show your reasoning. I think we've done everything. We found the leading term. We found the degree. We're good to go. All right, so I am going to actually, let me see. I know that the next slide is on the same problem. Okay, it erased all my work anyways. All right, so here, what can you say about the horizontal, which means the x-intercepts, and the vertical y-intercepts of this graph? Okay, so one thing at a time. I'm just going to rewrite what the standard form is. V of x, and if I forget it, hopefully I don't. All right, so it was, I believe, oh, see, I already forgot it. No. Okay, wait. 4x to the third. See, Miss Karen has a horrible memory. 4x to the third minus 45x squared. Okay. Minus 45x squared plus 119x. All right. So without graphing it, what can you say about the horizontal or the x-intercepts, right? And what can you say about the vertical or the y-intercepts? So I'll give you a little hint. The horizontal, those x-intercepts, the form that's easiest to see those in is this factored form here. All right. If I want to find the y-intercept, then standard form is where I'm going to be looking. Okay. So let's start with horizontal. So I'm looking at each factor and asking myself, hey, what would x have to be to make this entire factor 0? All right, so let's see. Remember, I want the entire factor to be 0 in order to get my x-intercepts. So 14 minus 14 would give me 0. So 2 times 7 would give me 14. So one of the x-intercepts would be, that looks like a y, I'm going to fix that in a second, would be a positive 7. Because when I replace it right here, 2 times 7 is 14, and 14 minus 14 is 0. Okay, so let's do for this one too. 8.5 minus 2x. All right, so I know 8.5 minus 8.5 would give me 0. So I need to figure out, all right, what do I multiply 2 by to get 8.5? All right, so I'm thinking it's a little tricky because it's like a decimal. But all right, so if I want to know what multiplies by 2 to get 8.5, I could just take my phone, right, and do the inverse operation. So the opposite of multiply is divide. So I'm going to put 8.5 divided by 2, right? And that gives me 4.25. 4.25. Okay. All right. So when I replace this 4.25 here, 2 times 4.25, right? If I think money is 8.5, right? 8.5, and 8.5 minus 8.5, again, is 0. All right. Here, this is weird. It's just an x. What do you think I would replace that x with to get this whole factor, that whole parentheses, to be 0? Okay. It's a little tricky, but then it's also kind of the easiest one. If it's just an x by itself, you just make that x 0. Okay, so if I'm looking at this graph, I will be having a x-intercept at 0, I'm just approximating, 4.25, and then again at 7. Okay, so I'll have 3 x-intercepts, and they'll be at those places. Okay, cool. So now the y-intercept is a little bit tricky. Okay, the y-intercept happens when all of your x values are 0. Okay. So 0 to the third is 0 times 4 is 0. I'm getting a lot of zeros. When I replace all of these x's with 0, then I'm going to have 0 plus, or 0 minus 0 plus 0, right? And that, sorry. So that would tell me that my y-intercept is also at 0. So this point right here, you would have a point 0, 0. Okay, so that would be your y-intercept. You can also think like if you have like y equals 2x plus 5, right? And I'm just kind of making this one up. My y-intercept is always the number with no variable. So if you look over here, all three of these terms have a variable. So that kind of clues you into, this doesn't have a y-intercept, or I guess it does, but that y-intercept is 0. Because see, I could actually just add 0 to the end here, right? And that doesn't change anything. It's fine. But it lets you know, hey, this y-intercept is going to be 0. Okay. All right. So I think that we have those all set. All right. So I'm going to clear the screen. Actually, I didn't need to clear that screen, but whatever. Okay. I'm relearning how to do these. All right. So one of these matches has 2 cards. When I looked, most people here, in whatever class, maybe not for all of the classes, but in most of the classes, you got this wrong because you were trying to split 3 and 3. One match only has 2 cards. Okay. The other match would have 4 total cards. All right. So with that in mind, if I am trying to find the leading term in the polynomial, I'm going to go standard form. Okay, so remember the lead term would be this x squared. It is the entire term with the highest exponent. All right, so I can easily see that in standard form. Finding the vertical intercept, or the y-intercept is what we call that. That is also right here, right? So think back to the last slide that we just did together. Remember, the y-intercept is the number that is all by itself, right? It doesn't have any variables. So here the y-intercept would be at -6. All right, finding the degree of a polynomial. Again, this goes with standard form, all right? Because I can just look at this and say, oh, this is a second degree polynomial, okay? So you can find all of these really easy in standard form. All right, in factored form, all right, here we go. You can find the x-intercepts. Remember here, the x-intercept is 2, because 2 minus 2 is 0, and x can be -3, because -3 plus 3 is also 0. Okay, so I hope that helped. Please look back, because I'm telling you, like 90% of you did not match those according to like 4 cards versus 2 cards. So it's really important. Make sure that you're reading these and, double checking your work. Okay. Cool. So we have the box method. I'm actually not going to do this because in the class that I was in, and it seemed to me that most of you are like solid with multiplying binomial by another binomial. Okay. So we are going to skip this. And I think the next one that was requested was 15. Yes, 15. Okay. So here we are. So spotting these differences. Hopefully you notice that a whole heck of a lot of this is the same. Okay. So they have the exact same x-intercepts because they have really similar factors. The only factor that this g function has that the f doesn't is a 1/2 in front. Okay, this does not affect your x-intercepts or your zeros because there's no x with it. Okay, so that doesn't affect that. So how does it affect the graph? think maybe the next slide, oh, the next slide doesn't have, okay. Oh yeah, it does. All right, so we have f of x and g of x. Those are repeated in the next slide. And then they also ask you, hey, how is this h of x different, right? So I see, cool, it's got these two factors that are identical. And this one is actually pretty identical. So I've got x minus 2. If you notice, they just multiplied the x by 3 and the 2 by 3, right? So x times 3 is 3x. 2 times, or negative 2 times 3 is negative 6. Okay, so it's actually a little bit more similar of a factor than it looks. All right, so how does this affect the actual graphs? So remember, I told you that the actual factors don't change. And actually here, I'm going to take the 3 out of here. It's a common factor, the GCF. Okay, that is not cute, but you get my point. So 3 times x would give you 3x, and 3 times a minus 2 would give you a minus 6, right? So here you can see a little bit more clearly that this factor is the same as these two, right? And then I'll just write the other 3. All right, so while I'm doing, or the other 2 factors, while I'm doing this, think about, well, what would be similar about all of these graphs, and then what might be a little different? Okay, x minus 7. Okay. All right, here we go. All right, so let's actually ignore these. Okay, so these have the factors that we were talking about, right? So at 2, negative 3, and 7. And I see right here, I've got 2, negative 3, and 7. All right, so again, because those same factors are in all 3 of them, right? Here, I could rewrite it again, but hopefully you remember, you can take the 3 out, greatest common factor, and you're left with this same x minus 2, all right? So because of that, you really shouldn't see any changes where the graphs cross your x-axis. All right, so I'm going to turn this one on. So if you notice, the effect of this was this 1/2 made it kind of like made it a little bit lower. It like kind of stretched it out a little bit like this way, right? So it changed kind of the shape of it, like how high up it went, how low it went, but it did not change where it hit the x-intercept, the x-axis. Okay, and this one, I wonder if I can actually add an expression, because I want to just rewrite h of x the way that we did it on the previous slide. So I'm going to take out the greatest common factor of 3, and then remember, 3 times x is 3x, and 3 times a minus 2 is a minus 6, right? And then I'm going to put the other factors here too. 3 x minus 7. All right. So let's get rid of, can I choose color here? No, I can't. All right, whatever, be difficult. All right, so remember, this is your original. And when I put this factor of 3 in front, it just made it go, instead of having it kind of be a little bit more mellow, right? It kind of stretched it up like this, like it just like, it's a higher peak and it goes down lower, right? So it's interesting to know, again, the x-intercepts did not change. All right, so it's good to know how when a factor is 1/2, right? When it's a fraction, it gets smaller, the effect on the graph, and also when you multiply by a number like 3, right? That gets bigger and bigger. Gosh, as I'm doing this, I am remembering when we went over this the first time in your freshman year. All right, hopefully it's coming back to you. All right, here we are. This is where a lot of you were when you said, hey, at this point, you know. So let's go over it. All right, So May graphs the function p by graphing this function, right? P of x equals x plus 1 times x minus 2 times x plus 15. All right, so is this a quadratic? All right, and I'm just going to remind you, quadratics have the highest exponent as being x squared. Okay, so take a minute. And if it's not a quadratic, what would be the highest exponent that this equation would have? I feel like I need to play the Jeopardy music. All right, so I look, it has 1, 2, 3 factors, and the x-intercepts would be at -1, at +2, and at -15. Okay, so when I look at this, I see the +2, I see the -1, but what is missing? Hopefully you can see that -15 is not there. It would be somewhere over here, right? If it were part of the graph. All right, so let's see what the next slide has for us. All right, so excellent. They really want, I don't really care if you zoom in or out, like, you know, whatever floats your boat. It is a little bit more accurate to use this wrench. So because I know I want my x-axis to include -15, I can go to the wrench. Let me move myself. Can I figure out how to do this? Yes. Yay, Miss Cram learning new things. All right. So here on my x-axis, it goes from -10 to a +10. And as you see, we're at -10, and then over here, +10. So I'm going to change this to like -20. Great. And then as soon as I do this, look, the x-axis goes to -20, and now I can see all three. So here's 1, 2, 3 x-intercepts. So it is not quadratic, right? This would be cubic, where you go up, down, up, all right? Or it could be the reverse, right? You could have gone down, up, down. Wait, I think I said that right. So, all right, so that's all they wanted you to do there, right? Just make sure that you can manipulate the window so you can actually see the entire graph and not a part of it. All right, and then you can, you know, if you want to scroll out or zoom out, zoom in, you know, I'm not gonna, you know, care too much. Okay, so here I'm graphing an equation that has the following horizontal, and again, horizontal is x-intercept, like the horizon, of 4, 0. So again, what part is the x? It would be this 4 part. So if I'm doing an equation, I'm just doing, all right, y equals, and I know that one of my factors, in fact, the only place it crosses is 4. So I'm going to say, all right, if x is 4, then I need to subtract 4 from it to get to make it 0, right? To make it an x-intercept. So I look over here. I have an intercept at 4, 0. That's exactly where they wanted me to have it. Great. All right, let's go next one. Now I have 0, 0. So I want an x-intercept here at 0 and then here again at 4. All right, so I'm going to say y equals, and remember, if it's 0, you might have to think back to a few slides. We just put x. That's it. You could put it in its own parentheses, but you know, I'm just leaving it like that. And then here we have a 4 for the x, right? So if x is 4, I'm going to subtract 4 from it to get a +4 intercept. Okay, so I look over here, 0, 0, 4, 0. All right, and I'm going to do that for all of these, right? So here I have -2, 0, and 4. All right, so let's just get this done. Y equals, so one of them is going to have negative 2. So if x is negative 2, then I've got to add 2 to that to make it 0. 0, 0 is just an x. I could give it its own parentheses. Great. Okay. And then the next one is 4, 0. So if x is 4, I've got to subtract 4 from that. All right, so let me just check. I've got negative 2, 0. I've got 0, 0. And I've got 4, 0. Okay. So, and sometimes like this bothers me just being here. It's not wrong. It's just like, so I like putting that X by itself in front. Tomato, tomato. All right. So here we go. 26. Same thing. I'm not even going to explain it again, but I will show you an example of what that looks like. So X plus 4. 0, 0. And you guys know I like putting that. Oops, not there. Here. And if it's 2, I've got x minus 2. So again, I'm just checking negative 4, 0, 0, 0, and 2, 0. Got it. All right, I think we're almost done. Okay, same thing. So if x is negative 5, I need to add a 5 to that. If it is a positive 0.5, right? So if x is positive 0.5, I've got to subtract 0.5 from that. And then if x is a positive 3, I've got to subtract 3 to make it 0. So I have negative 5, I have a positive 0.5, and a positive 3. Oh, and then this really does help this page. So, if I am busy and don't have enough time to look at all of your slides, I can definitely go to this and say, oh, okay, they're having a lot of trouble with, slide 5, 10, and 15, that kind of thing. All right. Well, thank you for watching. And I hope that these are helpful. Email me if there's anything I can do to make it more helpful. Just kind of let me know and I will do my best.